Okay, I guess we'll get started, and if anybody else joins, you can just join a little bit late. So good morning, and thank you guys for attending today's webinar. Srinath Kopal will be presenting his webinar for you guys today, which will be covering some very intriguing topics. We ask that you please keep your microphones muted and direct any questions you have to the conversation button, which is located on the bottom of your screen. It's right next to that hand icon. And now, without further ado, Srinath will begin his presentation.
Yeah, so thanks, Jake. Good morning and good evening, folks. So today's webinar is primarily related to the topic of digital transformation, but in the context of the current situation, whether it is the health situation or the economic situation. Things have dramatically changed over the last several months. And a lot of companies are thinking about how do we fine-tune our digital transformation journey, keeping these constraints in mind. Okay, so this is an attempt to discuss the same. So I would appreciate if you do have your questions, you can push them on to the conversation button, or towards the end, we should open it up for questions as well. So I'm planning about 30 to 35 minutes of presentation, and then after that, the rest of the time would be discussions. Okay, so with that, I will give a brief introduction of Prolim, who we are. So we are a 15-year-old company. We are headquartered in Farmington Hills, Michigan, in the US. We started off in the automotive industry, and we have grown in almost every industry vertical we can think of, and we have global operations across various continents, in the US, in Asia Pacific. So we have 9 global offices. We have about 400 plus customers, and we have been working for the last 15 years trying to give value to our customers. So what are we doing? We are essentially into 3 main areas. We started off as a PLM solutions company, where we provide services on Teamcenter. But now we also sell, we are a big reseller of Siemens. Recently we became a platinum member of platinum partner with Siemens. So we have a good support desk in Cincinnati, near the Milford office of Siemens. So we have a big support desk where we support the 400 plus customers who use Siemens tools. We have a training facility in most of the facilities in the US. And we also provide consulting services on PLM. If anybody wants to deploy a Teamcenter, or they want to migrate data from legacy tool to Teamcenter, and so on. The second business unit we have is on IoT. Essentially, the primary focus is on industrial IoT. Having said that, we also have we also have capability on the product IoT as well. So on the IoT side, we mainly work with the Siemens technology, which is MindSphere, and also with the AWS stack, namely the IoT Sitewise, Greengrass, and so on. So we work across AWS and MindSphere, doing various projects on collecting data from assets, either deployed in the field or in a shop. Okay, the third one is the traditional IT solutions, which is, which I think everybody knows. So these are the 3 main business units of Prolim. So coming to today's agenda, I would like to spend a few minutes setting the context. Okay, so when we talk about digital transformation, primarily from a product development and manufacturing perspective, I would like to take a few moments to discuss the context in terms of how it has evolved over a period of time. Okay, so that is one topic I will discuss. The second one is, what are the drivers for digital transformation? What is driving companies to transform themselves? The third one would be the impact because of the recent pandemic situation. And the last one is about what are the technology trends we can look at from a futuristic perspective. So if I try to fold the future in, what are those trends that we can look at from the futuristic perspective? That we will take a look at that as well. Okay. So with that, let's try and understand the history of manufacturing. Okay, so just to give you an idea, manufacturing is not new, and it's been going on for several thousand years, right? So metallurgy has been there for almost 6,000 years. Okay, whether it is making swords or whether it's making instruments made of metal, I mean, it's been there for a while. Forging, casting, they are the oldest technologies that humans invented. What has happened in the last 100 years is that, or 150 years, is that electricity and electronics have brought in a lot of improvements, especially in the metal cutting or the metal manufacturing industry. Okay, in that domain, a lot of improvements have happened, specifically on CNCs. Why even? I mean, it's not just CNCs for cutting metal, but instead of putting a cutter, you put a probe in, and it becomes a measuring machine, right? And then you put the measuring machine on one side, the cutting machine on the other side. You combine these two, it becomes a copy milling machine, and that's how people used to reverse engineer products for a while, about 40, 50, 60 years back. But over the last 2 decades, a lot of changes have happened from material science perspective that has brought in a lot more type of material, not just metal. So plastic composites. And what that has done is it has created new technologies of manufacturing, which are essentially 3D printing, additive manufacturing. Again, these have been there for a while, but they were very limited in the sense mostly focused on prototyping and so on. Okay, now it has been scaled up and people are using it for production as well. Okay, so this gives you an idea in terms of what is the history of manufacturing. Let's look at the other angle, which is the history of product development. Because to manufacture something, you have to have a product in mind, right? So let's look at the history of product development. So products have been designed, and some of the modern shapes that you see have a history in, actually goes back to ship design, right? The hulls of the ship, they were designed using instruments, physical instruments called spline. And in today's world, some French mathematicians took that concept and computerized it, which led to the advent of CAD and CAE tools. Right? And once that happened, then the entire 2D to 3D switch happened a few decades back. Right? Initially, it was all 2D designs, basically drafting, which became digital. And that digital drafting got converted into 3D designs over a period of time. And as and when more users started using 3D design, then the concept of collaborative product development was introduced, maybe a couple of decades back, a little more than that. Okay, so essentially what happened is a lot of silos were created in an enterprise. Right, you have engineers who conceptualize and design the product. You have vendor development or supply chain management that looks at how do I make it inside or how do I buy it from somebody else. Right, they decide it, and then whatever they want to buy, they send it off to suppliers. Whatever they want to make, they send it to the shop floor. So silos were being created over a period of time, and that is when collaborative product development was introduced. And that's how PDM and PLM came in. And recently, systems engineering has become more mainstream. Okay, so what I mean by that is products were, when you started off many years back, it was all mechanical products, right? Electricity came in about 2 centuries back, and electronics came in maybe about a few decades back. Okay, now the tide has been shifting. You have products that are no longer just mechanical, no longer just electrical or electronics, but it is a mixture of all the 4 domains of mechanical, electrical, electronics, and software. Okay, so that is how the product development has evolved over a period of time, right? So how have products evolved? So let's look at that perspective, right? So The idea is first I'll give you a perspective of manufacturing, then development, and the product itself. Right? Then we know where the products are going, and that is when we will be able to realize what changes we can make. Right? So if you look at the products were all custom made for several centuries using hand tools. Right? Whether it is very simple products, very complicated products, intricate products, it was all handmade. Right? The first and second industrial revolutions brought out the so-called modern assembly plants where products were mass manufactured, right? But mass manufacturing came with a constraint. You could not customize it, right? I mean, the most famous product is the Ford Model T, which is, I mean, you can get it in any color as long as it's black. Okay, so that was the downside of customizations. I mean, no customizations for several decades because of mass manufacturing. However, new technologies, modern technologies like computing, visualization, processing speed, cloud, all these things allowed for adaptability and allowed for flexibility, basically allowing products to have multiple configurations. And we are entering, if you notice it, the first and the last, right? We are going back to the traditional way of mass customizations, but customizations, but produced in mass, right, through newer technologies. And this was predicted by one of the professors in University of Michigan, Dr. C.K. Prahalad, who gave the concept of n equal to 1. Right, and that is what we are going through right now. Okay, so this gives you a perspective of where the products are going. Okay, so I'm sure everybody was talking about digital transformation for drivers for digital transformation. We just saw that individualized products, basically mass customization. Of course, people like fast delivery, right? You order something, you don't, I mean, in this age of instant gratification, if something doesn't arrive in 2 hours or 2 days, I mean, you wouldn't buy it, right? I mean, you go to Amazon, you go to any of the e-commerce stores, you need delivery right next day or within the same day. You need at the same time best quality, right? No people, whether it's low cost, high cost, doesn't matter. You need the best quality. And we are entering an era where a lot of things are talking, I mean, you're talking about sustainability of the planet. So you're talking about sustainable products, you're talking about healthy products, and people would like to know where the products are being made, right? There's a big trend towards, for example, there are certain, even if you buy grapes, right? When you buy it from the grocery store, some companies are smart enough to have created certain technologies by which you scan the QR code or the barcode on the grape aisle or the fruit aisle, and then you the complete history from which farm it was produced, where it was processed, and how long it took to come here, right? So people want to know, people have technology, they have tools that can give instant information, and products have to be smart enough to even understand where it came from, right? So these are some of the key expectations. This was pre-COVID, but you can see that products are getting more and more complex with increased complexity across mechanical, electrical, electronic, and software. These were some of the drivers for digital transformation. But what happened 6 months ago, right? The additional complexities. We had people working remote, and there was, I would say, constraints related to transparency of activities or tasks done by employees or by project members, where because of remote, I mean, not coming to work and sitting remote, you had to have better access and better transparency. Product visualization, especially in product development, became a big issue because earlier in a specific combined office location, the vendor development folks could walk over to the desk of the engineer or the manufacturing person and talk about the product. They would have a prototype, a physical prototype, they would talk about it, and then they would discuss the various attributes in terms of selecting vendors or selecting manufacturing processes and so on. But with remote work and with this particular pandemic situation, product visualization became a big issue. How do you collaborate? And then you need to have, again, a single source of truth of product data. Again, whether various functions, right? These silos of an enterprise, whether it's design or engineering or manufacturing or suppliers or service or finance or sales and marketing, everybody has to have the same source of data. Okay, especially when it comes to mass customizations, the sales team need to have as much access to the product information, to the bill of material, or to the cost models of the product as much as an engineer or a finance person, right? So more people need to consume that data that is being created by engineers or by the product development team. At the same time, you need to provide secure access to several gigabytes or possibly even terabytes of product data. So how do you incorporate these complexities, right, into your digital transformation? So if you ask anybody, right, what are your typical objectives? I mean, these are very generic objectives that any product company will have. How can I increase my flexibility? How can I deliver more product configurations? How can I reduce my batch size to one? Right. I mean, to give you an example, in the construction machinery industry, there are millions and millions of configurations. And if somebody wants to buy a construction machinery, it is more or less customized. It's almost the n equal to one or the batch size one. Right. So that is the kind of flexibility that companies are looking for. How do you reduce your time to market? This hasn't changed over the last 2 decades. People want to reduce the development time. I mean, I remember when let's say a car was being produced or new design was done in 72 months, which is 6 years, and now down to 11 months, literally, or 12 months. So there's a drastic reduction, and there's continuous pressure to reduce the development time because you have to produce new products every 6 months, every quarter, every year. These depend on the category of products. A cell phone maker would like to push a new version every 6 months or a year. A car maker would like to push a refresh every year and maybe a new platform every 3 years. Or an apparel or a shoe manufacturer would like to push updates every few weeks, 6 weeks maybe, right? So that's how you are. I mean, the companies are facing pressure in reducing the development time. And finally, when it comes to manufacturing, how do you increase your productivity? Okay, so these are some of the typical questions or typical objectives, I would say, for CXO, right? So there is a way to get there. Okay, so the way to get there is by combining what we call the virtual world and the real world. Okay, so what happens in the virtual world is you are designing digitally your product in the virtual world. And then you have to realize that product and optimize that product for the real world using certain technologies. And more importantly, what has become very important nowadays is once the product comes out, you need to measure the performance of that product so that when you make the next version, when you version up your product, it becomes better. Okay, if your product version is 1.0, then 2.0 has to be better, otherwise you run out of business. It's as simple as that. So this is the high-level framework that is there to essentially bring your virtual world and your real world together, right? So to break this a little more, your virtual world consists of basically 2 domains. One is the product domain, where you actually work on the product, you conceptualize the product, you design the product, you engineer the product, you analyze it for various attributes of the product, from a functional perspective, from regulation perspective, and so on, right? So there are a lot of things that you do on the product development or the virtual product side. Then the next step is the actual virtual production. So before it gets into actual production, today we have tools and technology by which you can create a virtual production and validate all the tools needed to produce that product, including everything from ergonomics, accessibility, the processes, the cost of the processes, all that can be simulated upfront. And once you do that, Then you get into real production, where there's again tons of automation. And then once the product comes out, then you actually measure the performance of that product. Okay, so there is a closed loop between the performance data that goes from production to virtual production, or from real product to the virtual product. And this becomes a cycle. And to manage all this is a collaborative platform, what we call, the industry calls it the digital thread, that stitches all the various functions of an organization in accessing this data, right? So how do we get there, right? I mean, this is all nice from a theoretical perspective in terms of how do we, I mean, what is it available today, right? But what is so the questions asked by many companies, small companies, medium-sized companies, even large companies is, this is all good, but is there a roadmap, right? So this is where we try to project the axes of what we call as the digital thread versus the digital twin, right? And then there is a way to get there. First is that you have to digitize your processes. Okay, that's the first step. I'm sure many of us have already gotten there. We know what digitization is. We are not using paper anymore. Instead, we have Word documents. We don't have ledger books. We have Excel sheets, and so on, right? So digitization has been around for over 2-3 decades, and most of us have crossed it. What beyond that? Next step is to organize, because there are several silos in the organization. You still have to manage the data. So you need some kind of collaborative platform by which you collect the data, you organize the data so that everybody looks at the single source of truth. So that's the organization part. That started the PDM or the PLM revolution 2 decades back. Okay, and then once you organize it, next is you start connecting all the functions. So product data has to be visualized in different ways, right? An engineer wants to look at the functional attributes. A designer wants to look at the actual shape of the product. A finance person wants to look at the cost of the product. A vendor development person wants to look at, okay, what are the individual parts that I need to send out to various suppliers? A manufacturing person looks at it from a different way, right? So once you connect it, each of them will have their own level of simulation, right? So an engineer would do typically what we call as finite element analysis or computational fluid dynamics, different types of analysis, thermal analysis, structural analysis, and so on. A cost engineer would do a cost analysis or a cost simulation, right? A manufacturing person would like to simulate the manufacturing processes. So again, these are technologies that have evolved over a period of time, and today now we have the ability to simulate. And not many companies are there yet. Most of the companies have done the digitization and the organization to a large extent, but the connect and simulation is where a lot of companies are putting their money and effort. After that comes, once you simulate the data, again, you have tons of data. Okay, data is created after simulation. Then you put a lot of artificial intelligence, machine learning, use those to start to analyze the data. Right? And what is the advantage of analyzing the data is now you will be able to predict what your product is doing. Okay, or you'll be able to predict the tool. Right? So those are the things that would essentially, I mean, that is what the prediction does. And once you predict, then you'll be able to prescribe to your end user, whether it's a customer, whether it's a consumer or a business company, right? So you'll be able to prescribe the product. And that is how you realize various levels of digitalization, right? So this is a journey. It's not something that you can turn on or off. Okay, so this is a journey that you have to go through these various steps. Okay, so how do you bring the various things together in the digital thread, right? So as I said, a lot of companies operate in silos. It's by design. There's nothing bad or nothing good out there. I mean, it's by design. That's how companies have evolved. This is how companies have grown, right? So how do you bring various functions? So a sales department looks at RFQ management. The product development team looks at design management or engineering management. Finance looks at cost management. And then the vendor development looks at BOM management and supplier management. There's a PMO office or program management office that looks at program management. Manufacturing looks at it in a different way. And finally, change management has to be, you have to stitch all these together using that. So if you look at it, these are all the elements of a typical, I would say, a PLM tool, okay, which started off as PDM or design management 2 decades back. And today, I think technology has evolved to an extent where all these silos can be stitched together so that a single digital thread will bring the organization together with a common backbone of the product data. Okay, that's the digital thread part. Now, once you have the digital thread, then you get into what we call as the, if you go back to those 4 slides, I mean the slide before where there was those 4 circles, now we're talking about the product twin, or we're talking about how do you bring together your virtual product development that can then correctly create a twin of the actual product, of the physical product, right? So this is the concept of systems engineering that brings together your mechanical, electrical, electronics, and software together. There are tons of rule-based automations that many people have done already on the mechanical side. We're extending that to domains. Again, material sciences has played a big role in changing the type of products that are designed, not just metal products, but also composites, plastics, and so on. There are, again, machine learning and artificial intelligence-based tools for topology optimization, where you don't have to do the actual, I mean, you can give basically a framework of the design saying these are the constraints, and the software will automatically create the topology that can then be 3D printed. Okay. Again, multi-domain simulation, verification and validation. So all these are the various aspects that create the digital product twin. Once you have the digital product twin, then comes the actual production twin, okay, where you have to validate the dimensional quality, you have to validate the layouts, the capacity optimization, the tool validation, and so on. Okay, so oops, let me run this video. So you can see here that there is a robotic simulation that is done up front before actually you commission the robot, right? So this is a very simple, some kind of a box build for a PCB, right? So when you're building this box, you're able to simulate all the robotic programming upfront before you invest in the robot. So there's a tons of savings here. Otherwise, you'll be spending money in buying the robot, in testing the robot, and again, you would be a lot of time and effort goes in there. So all that can be optimized by doing it upfront. And similarly, you don't just have additive manufacturing or subtractive manufacturing, but you have a hybrid manufacturing. Very interesting case study of how a turbine blade, you get the basic shape done through additive manufacturing, and then you remove only enough material for the actual correct, precise shape to be generated, right? Pounds or kilograms of metal, you're only removing very small quantities of metal. So there's a lot of cost savings out there. Okay, so these are some of the ways in which the production twin can be realized. Okay, the next one, if I can get I can jump into the next slide. Yeah. So as you can see, some of the key technology drivers that are driving some of these are embedded into these digital transformation tools. So we have various tools leveraging neural networks through artificial intelligence and machine learning. So there are some good concepts being that are coming out in the near future where, for example, you want to classify your parts, your library of parts. So today you're doing it manually, but tomorrow you can teach the computer to do it. You can teach the computer saying that these are the shapes of a fastener. Please classify all these, and it'll come up with its own, using neural networks, it can classify and it'll give you it'll get the job done. right? And we saw how additive manufacturing is also changing a lot of the supply chains around the world. You don't have to do it in one big. I mean, no longer are a very interesting discussion with at the University of Michigan, where they were talking about the future of manufacturing 25 or 75 years down the line, where one of the big three OEMs came there and said that, hey, in about 75 years, I would be building my vehicles or my the futuristic vehicles actually on a floating ship. Okay, you have all these AI ML tools that will make sure that despite the various tides and things going on in the ocean, the plant is pretty stable for it to actually produce vehicles, and then it'll go from continent to continent and deliver these vehicles as per the demand. Right, so those are these that are, I mean, futuristic concepts that are being created by some of these companies. And cloud is playing a very big game, especially post-COVID. A lot of companies have realized that their current infrastructure is not suitable, and they're going for better infrastructure, or I would say more, infrastructure that is more fine-tuned to remote access. And cloud is playing a big game there. And the last one is data analytics. As more and more data comes out from these smart products, how do you analyze it and make your product even better? Right. So with this, I would like to end with one slide, which is more, I would say, you can in a way pick your path forward, right? So there are different ways in which your company can shape the future, right? So I have termed it as the 3 I's. You have the inertial way, basically using inertia. You have the path of greatest familiarity. Whatever you're doing, you're very familiar with that. You continue with that, but possibly, I mean, as products evolve, you may see a very short future, right? Then there is the path of least resistance, where you're trying to imitate somebody. Again, yeah, I mean, you can only do that for certain amount of time, then you'll have to pick somebody else to imitate. And then finally, you get into the last one, which is the inventive approach, where you have the path of greatest opportunity. And that is where I believe a lot of companies, especially companies that are growth oriented, would look for the third option. And this is something that I learned from my professor at the University of Michigan. So I thought I'll end it with this slide. So yeah, so with this, I would like to open it up for questions.